Hello and welcome to Coding for Industry 4.0. This is this week's hardware lab, and if you notice, it's not hooked up to the computer right now. So this week we had to create a dice, basically a digital hardware dice. So instead of having a dice I roll, built this little program using the NeoPixels to represent the 1 through 6 sides of a dice when either the A or the B button are pressed. So the reason I printed this out, and I'm doing this with my little tool hooked to this little battery, is to show that we are getting to the point where these programs can run and should run without the computer. So I'm gonna wait for that flash. So I'm going to call this out right now. I don't think this battery is providing the full voltage that this little microcontroller needs. So I think what that yellow is like a brownout warning. So I think the capacitor fills up. It probably doesn't fill up to its time or whatever. Who knows? Like, I'm not even going to speculate, right? The magic of the black box, it's in there. We're not going to look behind the curtain. So that's what that yellow flash is. But in between that yellow flash, I'm going to do it so we have the time. In between the yellow flash of warning, the program works. See? There's a 3, there's a 1, yellow flash. There's a 1. Oh, wow, getting a bunch of 1s here. Oh, there we go. There's, So there's a 5, there's a 6, there's a 2, brownout. There's a 3, there's a 6, there's a 1. So, again, the reason I did it this way without it hooked up to the computer was just to prove and to show the reason we build these little encapsulated codes is so we can actually start making little tools. So we made a dice. I'm gonna go hit the boardwalk, and instead of shooting dice, I'll just pull this thing out and do a little hustle, right? So anyway, this is coding for Industry 4.0. We created a hardware dice using the buttons as the input and the NeoPixels as the output. And this thing likes 5s. There we go. So what it does, every time you hit the button, so it starts here. So boom, here's the thing it calls out. While true, if the buttons are pressed, the first thing it does is it clears whatever pixel was there before. So we'll hit it and it'll clear that 5 before. So it's happening super fast. So it clears out the whatever happened before, makes all the pixels shut off with a 0. Then the dice roll happens. It creates the random number between 1 and 6. If it was hooked up to a computer, you could see in the REPL what it pops out. Value 1 equals random integer. So this right here is where you start getting your color values for your LEDs. Okay. So then what this one does is it uses 3 different color values because the NeoPixels have, you can zoom way in there. You can see actually several LEDs in there. That's how you get your color change. So this creates 3 separate colors every time. And then down here, so then you have, it comes on, the value, it values of 1 through 6 NeoPixels, but then it combines those 3 values from up here to make a true random color. Like, it expands your random colors so much, it gives you the full like pinks and greens and blues and all the other things in between. And then the yellow flash. But see, yeah, dice. Okay, and then yep, so it puts it all together. And the sleep, so you don't even have to press the button. So it has a sleep of 2, and if you just hold it, every 0.2 of a second, it activates as a button switch. So that's kind of neat. So yeah, I'm Clancy Moody. This is Coding for Industry 4.0, Dice Lab, hardware dice lab, and that is a hardware dice connected to a battery that isn't providing it enough power.